Hi everybody, I just thought I'd give you a quick update on how we manufacture the flasks. We've changed the manufacture very slightly. There's a couple of reasons for this. One, the main body of the flask, which is what we're going to be doing today, I had to have quite a large lathe to do the routing out of the centre of it, the chambering out. That lathe was nearly 2 tons in weight and 2.6 metres long. And eventually, after so many years of doing other stuff with it, we stopped doing the other stuff and just concentrated on the powder flask and a bit of wood. So the lathe had to go. It was taking up too much room. So we needed another method of manufacture of the body. So a couple of years ago, I bought myself a CNC router, only a small one, nothing industrial. It was only a hobbyist one. And sort of did some other things on it, and then realised that I can actually do the wooden part of the powder flasks on the CNC Carver or CNC router. Hopefully at the end of the video I'll show it actually doing its job. Now I realised that that doing it with the CNC router for hobbyists is perhaps a little bit too much. You can quite easily do the work that I'm doing with just a normal router, a pencil, and you can mark it all out and get it all done. But unfortunately, I'm having to do this job quite often. If you consider how many powder flasks I've made over the years, it's well over 500 powder flasks, and they're still selling. They still go all over the world. So I thought, well, if I do the design onto I can cut it out on the CNC Carver CNC router, then it's going to make it a little bit easier for me. I will get repeatability, which is important because all the flasks need to be sort of very similar in shape and same. So I decided to go down that route. Now, what we'll be doing is we'll be designing this part, which is the wooden body, on some software. So that's basically what we're doing first. We'll design it on the software, and we'll show you within the software it cutting it out, and then we'll show you it actually machining it out later on. Now, all these powder flasks are all hand finished. They're all finished by hand. So really, it's a hand finished job. There's no much difference into what I was doing before, except I was using bandsaws, large lathes, and what have you. So that's what we're going to be doing today. Now, there are so many different types of software out there that you can use to design on. You can use any 2D CAD software. You can use the facilities, the programs that are out there. There's 3 programs which I currently use. The first one, which is Easel, which is it's free, it's web-based. It's quite good. In fact, I'd probably use it 85–90% of the time. But in this instance, I'm going to be using what they call Vectric software. Unfortunately, we have to pay for that. The difference between the two is that the Easel is only 2D design, and the Vectric software is 3D design or 3D cutting. And there is another program which I'm currently sort of trying to learn, which is Fusion 360. And Fusion 360 is very powerful. Unfortunately, it's also very complicated. So we'll be doing it on the Vectric software. I'll go through all the steps of how we do it and what have you. If you've got software, Vectric software, and your CNC Carver, you're very lucky. You can cut one of the powder flasks out if you wanted to make one yourself. But as I say, for the single, if you want to just make 1 or 2 powder flasks, it's going to be just as easy to mark it all out on a piece of wood and then cut it out with a router or whoever want to cut out the chamber bit, cut it all around it and do it yourself. But as I say, I have to have repeatability. I have to do quite a few of these at a time. So that's the route that we're going to be taking. Now, what I did is first was I took the template of the flasks that we're going to be doing, and I put it on a piece of paper, and I drew round the template. Okay, and I'll show you that drawing shortly. and then I measured certain areas of that drawing just with a ruler, nothing important, anything like that, just with a ruler, and I wrote those dimensions down. So I've got a sketch which I will be using to refer back to when I go onto the Vectric software to design within the Vectric software. And within that Vectric software, I will be able to put the two cutter tool paths in to show you cutting it out. And then from that, I'll save the programs. It then goes on to the CNC Carver, which is run by a very old laptop, and I will sort of transfer the program through to that machine, and then we'll cut it. We can run it from the Vectric software, but unfortunately, if you're using the laptop for the cutting machine, then I can't be designing on it at the same time, because I'm designing the house and I cut in the garage. So I'll try and put the drawing on next, and then what we'll do after that, we'll go on to the Vectric software and we'll design on the Vectric, and then we'll go and cut it. Okay. Okay, so here we go. We're going to be starting doing the drawing now, but first of all we need to set up the material which we're going to be using, the sizes of the material we're going to be using. So we've set up a new job. So we're going to do a single-sided job. We're only machining one side of this. The job size, the width is 240 millimeters of the material that I've got. The height is 400 millimeters, and the thickness is 23. Okay, the Z0 position we're going to be using is going to be the machine bed. The advantage of this is that if I was to use a different material, should we say it's only 22 millimeters thick, later on using the same sizes 400 by 240. If I was to use the top face of the block of wood of my Z0, then all the calculations, all the tool paths would have to be recalculated. With this method, if I use the machine bed as a Z0, anything that's 20 to maybe 30 millimeters would still cut. But I know that most of my powder flasks are between 40 and 46 millimeters wide. Half of which 46 is 23, so if I use that as the largest one, then that's going to be okay. I'm going to use an XY datum position as this bottom corner here. We can see a little red triangle, little red thing there, and that's the material that I'm going to be using. That's the XY0 position I'm going to be using. The resolution which I'm modelling is going to be the fastest resolution, because I'm going to be sanding all this lot up, so it's going to be okay. And the material settings, I'm going to use oak light. So it was already set on oak light, wasn't it? So I'll just come off that anyway. Okay, and that's the material set up now. Now we've got two views here. We've got the 2D view, and obviously we've got the 3D view. The 3D view is only showing the material at the moment. So I'll go back onto the 2D view and we'll start the drawing now. So the first thing I'm going to do is going to create two lines. The first line is going to be along the bottom face of the powder flask. The second line will be the top face where the catch goes. So let's start off with the line command, which is here. I'm going to go X0, Y0, add that in, that's a start point, and then X110, Y0, add that in, and now we've now got a line down here. You can see I can still carry on doing that line, but I don't want to create a new line, so press escape and go on to a new line. So it's a line, and then look, referring to my drawing, I know that the start point of this line is X150 and a Y of 168, and add that in, that's a start point, and then the next point will be X170, Y125, add that in, and you can now see we've got a line there. Press escape, stop it from, that wasn't very good, was it? I'll delete that, so we're talking. Okay, so we'll do it, start that line again, apologies about that. So it's X 150, Y 168, add 170, Y 125, and add that in, and then close. So and now we've got the bottom line there, and then we've got the angled line at the top there, which will be the top face. So now we need to connect these areas here with an arc. So we'll create an arc, and again referring to my drawing, the start point of the arc on the outside is x0, y0, okay, and the end point of that is 150 in x and 168 in y. Now I can do this by setting the radius. I don't know what the radius is going to be, but I've measured the template, and the actual height is 40 millimeters. So we create that, and that's the outside arc done. Close that, come off that, and we'll create the inside arc now. We'll draw an arc. So the arc start point in this case is x110, y0, and the end point is x170 and y125. This time the height we're going to be setting at 30 millimeters. Create, and there's the arc that we've created on the inside, and then that's the outside profile of the powder flask. It's fairly quick. So what I want to do now, at the moment all these lines here, or vectors as we call them, are all separate, which at the moment is an advantage, because what I want to do is offset this line here inwards by 20 millimeters, because that's the basic width of the top of the powder flask. So I'll create an offset, and then we'll put 20 millimeters, okay, and then we'll go on there. Now I'm going inwards. It may not work. It may go outwards. It has gone outwards, so I can actually go minus 20 on there. No, let's go inwards. Let's go outwards. Stop that off. Okay, close that. We can delete that line there now. Okay, oh come on, I must have done it twice. Delete that line now there. Okay, so now we've got the top thickness of the material of the powder flask. Now I want to create the inside of the powder flask. Now, like I said before, each of these vectors here are all separate, but I want to connect them all together. So I'm going to connect them, join all the open vectors, and then we're going to press shift and click on each of the vectors that we want to connect. You'll notice here we've got a tolerance of 0.5 millimeters. That's in case any of the endpoints of those vectors are not touching. I know they're touching because the points I put in are quite precise. I mean, you can put a larger figure in there. That's my dog barking. We can put a larger figure in there if you want. But we can join all those laws now with a 0.5 tolerance, and that's all joined up. So if I close this one here, close that down. So if I go like that, that is one vector. So when it comes to machine the outside profile, it will do that in one complete loop all the way around. Okay. So now I want to create as the inner profile. And in this case, I know that the wall thickness is 10 millimeters all the way around, apart from this top bit here, which is 20 millimeters. So I'm going to create an offset with a distance of 10 millimeters. I'm going to go inwards, and I'm going to be, that's the vector I want to do. Press offset, close, all done. Come off that. Now, as you can see here, we've got crossing lines, bits that we don't want. try and zoom in a little bit. There we go. Now I want to cut these areas away. Quite easy to do that. Use a snipping tool, and I can snip all these bits off. Fantastic. That's them all done. Close that. Okay. So now we've got the inner profile, and now we've got the outer profile. Now we've got sharp corners here, 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 and here. And obviously a cutter's rounded, so you can't have a sharp corner. And I know the cutter I'm going to be using is 13mm, which is a 6.5mm radius. So I want the radius to be slightly bigger than 6.5, so it rolls round it. So I'm going to create what they call a fillet, and that's going to be a fillet of 8mm. So So we'll now create the fillets. So this is the fillet command here. Create the fillets. We'll do a normal fillet, and the fillet is going to be 8mm radius. Okay, so what we do then is we click on each of the corners. 1, 2, 3, 4, and we're also going to fillet these corners here. Okay, and close that. So now we've got the powder flask as we want it, with an outside profile and an inside profile. But of course we've only really got one side. We've got the right hand side, should we say. So what we need to do is we need to create a left hand side. So the best way to do that is to mirror the component. So all I want to do is click on that, which is one vector. Shift and click on that, which is another vector, and then we shall mirror selected objects, and it comes up a bit slow today. Okay, and I've not done it right. It should be flip horizontally. Edit, undo mirror vectors, edit, undo mirror vectors, flip horizontally, which is there. Okay, close that. I can move this component now. I can move it somewhere up here. Let's have a look. You can move it up here. I can also swivel that component here now. So if you swivel that like that, just move it slightly to the right, and then come down, click on that one, and that one, move selected on, and then swivel this one here, and move it up slightly, like so. Close that area there. We have now got the two halves, the right hand and the left hand, but we've also got two areas here which is wasted material, and yeah, I don't like wasted material. So what I'm going to do, I've already drawn the smallest powder flask up, and in a different drawing. So what I shall do is I shall just copy that and that, edit, copy, go back to my original, okay, edit, paste, move that into there. Of course we need a mirror that as well, so I might as well click off it, click back on, do a mirror. That's the other hand of it. I can move that one up here. Fantastic. So now at that piece of wood I've now got 2 separate powder flasks. So now we need to do is create the tool paths. So if I go into the 3D view, you can see there's nothing happened on the 3D view. We haven't cut any material away yet. So on the 2D view, we need to do the inner profile first. So I'm going to go on tool paths and I'm going to pin that there. Okay, so what we're going to do is press shift and go on to all the inner profiles. 1, 2, 3, 4. So we're going to go on to the pocket tool path like that. I've already set the cut depth there previously, so it's actually I know the wall thickness on the faces are 6mm. So 6mm off 23mm thickness of material gives us 17mm. Okay, I've already picked the end mill which I'm going to be using, which is a 13mm diameter, which I stated before. I can actually use another one if I wanted to, but I'll at the moment the 13mm one is quite suffice. Right, how many passes do we want to do? If I edit the passes here, it'll show me that each pass is 2.83mm. So I'm going to reduce that down to 5, so it's 3.4mm, which is about on its limit for oak. I think there'll be a lot of noise on the machine, but it'll be okay. Okay, so we'll use that. Okay, so we'll use it on that many passes. Okay, I'm going to do an offset pass and not a raster. A raster means, as you can see, we've got a zigzag profile here, but an offset would start in the middle and work its way outwards. I'm going to climb mill, with the words the cutter's actually cutting into the material as if it's drawing the material into itself. So we shouldn't have any problem with that. And we're not going to ramp it. We'll not have a pocket allowance. We don't need to a pocket allowance. It's quite adequate as it is. I don't want to project the toolpath. Well, I will. I'll project the toolpath onto the 3D model. It'll show you which way it is. And then I'm going to change this one to, well, we'll call it pocket one. We'll leave it at pocket one for the time being. So I'll press a calculation there. It's calculated it all out, and now it's automatically gone onto the 3D view, and it showed me the tool paths as it's gone. So what I want to do is preview that. So I'll press preview here, and there we go. So that's the 4 pockets done. Close that. So on this 3D view, if I can swivel that round, you can see the 4 pockets already done, already carried out. Okay, so back onto the 2D view up here. So that's it, inner pockets done. Now we're going to do the outer profiles. So once again, click on each of the outer profiles. And this time we're going to do a profile toolpath. Okay, and the start depth is going to be 0 and the cut depth is 23mm. We're going to cut it all the way through the material. Okay, the passes, I'm going to use a 3mm cutter. Hopefully that should work. You could use a 6mm cutter if you want, but 3mm has always done okay for me. Edit the number of passes. Well, it's nearly 3mm per pass, so I think that's going to be okay. So we can leave that. Okay, we're going to go outside the profile, so it's going to go on the outside of that line, not on the inside of it or even on it. And we're going to climb mill like as we said before. We're not going to do a separate last path, but what we are going to do is going to add tabs. Now what the tabs do is they'll keep the material, the job stuck to the main material by adding a certain number of tabs. So if I press add tabs, we're already gone. The tabs can be 6mm long, 2mm thick, and at the moment we haven't got any tabs on that, which is rather unusual. So we'll look, how do they edit tabs, if want of a better word. It's got constant number 42, So we'll go up to 4 tabs. There we go. So the tabs are on every part of the component now. I don't like them on that top face, so I can move the tab around to there. I'll move that one up to there. Probably leave that one there. Yeah, they'll look okay really. I'm not gonna really worry too much about that. Okay, close. Okay. I don't want to add any ramps to the toolpath. I don't want it to sort of slide its way in. It goes plunge straight in. It's all going to be polished up this way. And then I'm going to project the toolpath onto the 3D model. We call that profile 2. We can actually pull that outer profile if you want. All done. Calculate that. And you can see now we go back to the 3D view, which the blue bits are the areas it's going to be cutting round. Preview that. And there you go. And that's your 2 powder flasks out of 1 piece of wood. Done. Okay, if you just look closely there and there and there and on the rest of them, you will see the tabs which are holding that piece of that component within the material itself. So we close on that. So what we need to do now, and what we didn't do before actually, we didn't actually save the actual job itself, so we can go back at some later date and edit it. So let's go and put save as. Well, we should be able to save it as somewhere. Well, why aren't we saving it as? There we go. We'll call it test 2. TEST2. Okay. Save. I've already designed all these before, so I don't need to do much more. So now we can do 2 things now. One, we can see how long it's going to take us by pressing the time key. So the pockets themselves are going to take 17 minutes to machine the pockets, and 21 minutes to do the outer profile, or the 4 outer profiles. And I can change the rapid rate if I want, but I'm not going to do that. So close. So what we need now is to actually save the toolpaths. So in this case, I'm going to save the toolpath of that one there. I'm going to save the toolpath. This machine's really slow tonight. Okay. Go into powder flasks. I'm going to call it test 2 pockets. Oops. And I always put the cutter size in. Test 2 pockets 13mm. Save. And I'll save the outer toolpath. Save toolpath. Okay, outer profile. I'll go back onto test 2 pockets. Outer, and I go 3mm, 3mm or 1/8. It's not going to make a lot of difference, so save that, and that's it done. So we've now designed and cut, or got ready to cut the 2 profiles. So we're now going to the next stage, which is loading it into the software, which will be used for the cutting. So I'll finish this bit now, and then we'll go on to the actual cutting of the components. So let's stop that now. Close all that, and we'll see you in the next bit. So this is the program which is going to send the actual codes to the machine. Okay, so we've designed it on one program, and and then we're now sending it to another program, and this is called GRBL Candle, GRBL Candle, and this is open source software, so it's free. It did actually come with the machine. So, and this will post-process the codes which we've already generated into the codes that the machine can read, which are basically G codes and feed and F codes and such like. So if I open, and then we'll go on to where we saved the files, put all files in. So we always machine the pockets first. Okay, so open this, and there are the pockets that we're machining. Okay, this is the cutter path it's going to be taking, and back to 0. And these are all the codes which we'll be using to create the inner profile. So it basically works on G codes and works in an X, Y and Z coordinates. So the first thing we have to do, these are all set, these are all done for me on the post processor. I don't have to do very much in here. And if I look down the list right at the bottom, there's 5,193 lines of code. So it's quite a lot of code there that has been generated. Every movement that machine makes, it's an XY movement or a Z movement. So if I was going from, shall we say, X0, Y0 to X110 and Y0, it will be basically 2 lines of code. It's not a lot, but don't forget we've got curves here. So all these curves here and all these inner bits here are all basically made up of very tiny straight lines. So that's the amount of code that you'll need to actually run it, and to do that longhand is very difficult. Well, it will be very nigh on impossible. So the codes there. If you're doing a straight square, you could just write that code yourself. You know, that's not too difficult. Or even an angled face, single angled face, is not too difficult. And bear in mind, quite a few years ago, that's how people used to program components, but just writing in the G codes, and G codes, the M codes, and the feed rates, and what have you, and the depths, Z codes. So that's already in. So we'll now send that down to the machine. We'll make sure everything's connected up. At the moment, you can see we're not connected here, but it's easier for me to show you offline than it is to show you online. And all these little commands here will tell me, for instance, this will be for setting the Z probe, setting the tool height. That's a home position, so that's a safe position. I can zero out when I'm in the right place. See, I could even zero out with the Z if I wasn't going to use this command here, and I can also jog along with these here. So right, left, up and down, and sorry, up and down here, Z, and then you can hover over it. It just tell you what it does. So as the codes are sent to the machine, it will this line will, if I start at the very top, this here will go all the way down and show me how it's being machined. Okay, so if I make a mistake, sometimes the machine does try and give up. It might lose its signal. You've always got a point that you can actually say, right, I want to start it from halfway through, and I know where you go. Okay, thank you. I will see you on the cutting side of things next. So now we'll zero the cutter out. We're all loaded in, ready to go. The piece has been clamped down, so we'll zero out the cutter. That's the cutter zeroed out. Turn the machine on. And we're ready to go. So that's all the 4 pockets done. Now we'll put the cutter in and do the outside profile. And that's the 4 cutouts done. I'll just show you them. I'll just move the cutter out of the way and then you can see them. So there they are. All I need to do now is unclamp the main piece of wood and then cut them out with a little bit of a Stanley knife, and they're all ready to go. So there we have them, all the pieces ready to be put together, glued together. and then after they've been glued we can polish them. Okay, so we've finished the bodies now. Here we have them here. We've once we glued them, polished them all up all the way around, put the radiuses on the edges here, and then we drilled a hole in the bottom for the filler plug, hole in the side here for a brass bar that goes across to hold the spring, and drilled and the holes in there and put the screws in for the catch at the top. So all it really needs now to be done is to actually first of all 2 coats of Danish oil to keep them waterproof a little bit, and then 1 coat of beeswax on the top. After that's all been done and polished, assemble the rest of the bits together. Well, I hope you've liked the video. As I say, it's just an insight into how we now do them rather than an instructional video to if you want to do one yourself. I mean, it's quite easy to do them. The wooden bodies certainly with just a router and a bandsaw or even a jigsaw, so and a sanding disc. So if you're going to make your own, good luck. We're still selling them. We're not finished selling them yet. We keep making them. If you want one, you can just visit my website, www.plantagenetrepros.co.uk, and you can order straight from the website. Or if you wanted one off Etsy, and if you wanted one off eBay, they're both on there. Prefer you to buy them off the website, then we don't have to pay those fees. So thank you once again, and if you're making your own, good luck. Cheers now. Bye.